So let's just talk for a minute about electric shocks while we're on uh, currents and so forth. Um, it turns out a dry human has a resistance of about 200 kiloohms. It depends heavily on the person. Some people are a little clammier than others and are a little more conductive. It just varies from person to person. It can vary with the humidity. All kinds of things can affect it. A wet human is about 10 kiloohms. Again, these can be off by a factor of 3 or 4 or 5 or something like that. And so exercise caution, err on the side of caution. And so you can just sort of look at these numbers and say, well, what currents do I get? It turns out that it's current that causes damage to you, not the voltage. We've already talked about, a spark from a wall outlet can be a spark from a doorknob can be 30,000 volts, but there's no energy there. There's very little current, and so not much happens. You just get a little jolt. But if you get a decent amount of current, and usually currents above 1 milliamp are noticeable. Above 5 milliamps start to get dangerous. And so safety begins. Safety considerations begin at the 5 milliamp mark. And so if we just take a wall outlet and figure out what the current is on a dry human, the current is just the voltage divided by the resistance. And so our wall outlets, never mind that it's AC for now, is 120 volts over 200 kiloohms, right? The voltage in your wall outlet divided by the resistance. This is like 0.0006 amps, or about 0.6 milliamps. If you touch your fingers to the wall outlet, you're probably not going to get much from them, unless you're wet, and then it's really bad. So if we, or it's just bad. So this is a dry human, and so for a wet human, the current is again V over R. But now instead of 20, I have 200 kiloohms. I have 10, and so this is 120 volts over 10 kiloohms. This is This is 12 milliamps. This would rattle your cage pretty good. Usually it takes more than that to kill you. But the problem with something like this is this causes your muscles to contract. And so if you just happen to grab a loose wire or touch a loose wire with your hand, that current will override the signals your brain is sending to your muscles and cause you to just hold on to that wire. And the sustained contact, the sustained current, is likely to can do things like affect your breathing and your heart motion and stuff like this. If this current goes through your heart, it can cause your heart to either contract wrong or just stop contracting. Same thing with your breathing if those muscles tighten up. And so there are a couple lessons from this. One is don't touch bare wires, but if you do, try to touch them with the back of your hand, because then your hand will recoil from the wire rather than grab it. And so anytime you feel like you're in a dangerous spot, just don't touch stuff. But if you have to, use the back of your hand to touch them. You also have less sensation back there, and so it's a little better that way too. But it's a big difference if you're wet or you're dry. If you get really wet, even a car battery is going to be pretty dangerous to you. If this is down to like 2 kiloohms and it's 12 volts, that's still 6 milliamps. And so you can get a dangerous shock from a car battery if you're wet enough. Now, usually your car battery is under your hood, so even if you're working on in the rain, you're at least mostly dry under there. But you should always exercise caution when when working with electricity anywhere, and it's always best to turn off circuit breakers in your house and test the switches before you start messing with anything, or better yet, call an electrician.